Why is regularization important for training neural networks? Imagine trying to memorize every detail of a huge book. It might help you pass a test but won't help you understand the story. That's what happens when neural networks memorize training data instead of learning general patterns. Regularization is like a guide that keeps the network from overfitting or memorizing and helps it focus on the big picture. When training neural networks, especially deep learning models with many layers and parameters, overfitting is a common problem. If a model learns the noise and specific details in the training data, it won't perform well on new and seen data. Regularization techniques add constraints or penalties during training to keep the model simple. This way, the model learns more general patterns that apply to different data, not just the training set. One reason regularization is so important is because it improves the model's ability to make accurate predictions on new data. This is especially true for applications like ChatGPT, DALL-E, or Midjourney, where models generate text or images based on prompts they have never seen before. If a neural network memorizes the training data, it can't adapt well to new inputs. Regularization prevents this by encouraging the model to learn the underlying structure rather than just the specific examples. Another key point is that regularization helps prevent neural networks from simply memorizing the training data, which can make them less flexible. Without regularization, the model might get stuck in a narrow solution that only works for the training set. Regularization techniques like adding penalties for large weights make the model less complex and more adaptable. This is important because overly complex models tend to fit noise, which leads to poor performance on new data. Regularization also makes training more stable. Techniques like batch normalization, which normalizes the inputs to each layer during training, act as regularizers. They introduce slight randomness that helps the model learn faster and avoid getting stuck in bad solutions. This stability means the training process is smoother and the model converges faster. Controlling the complexity of a neural network is another reason regularization is vital. Methods like L1 and L2 penalties add costs for large weights, discouraging the model from becoming overly complicated. This balance between fitting the training data well and keeping the model simple is called the bias-variance trade-off. When this balance is right, the model performs well on both training data and new data. Finally, regularization makes neural networks more robust. It reduces sensitivity to small changes or noise in the data, making the model's predictions more consistent across different datasets. This reliability is crucial for AI systems that need to work well in real-world situations, like natural language processing or image generation. In practical terms, regularization is a must-have for building trustworthy AI tools. It helps models like ChatGPT, DALL-E, and Midjourney produce meaningful, accurate outputs without overfitting. It also supports ethical AI by preventing models from overfitting biased or limited data, which can lead to unfair or incorrect results. Overall, regularization is a key part of training neural networks that are effective, adaptable, and dependable for a wide range of tasks.